Hi everyone and welcome back to Fundamentals of Engineering with Farhad, Fluid Mechanics. In this example, we review a problem in manometers and pressure. So we have like a manometer contains water, mercury and glycerin. So if the specific gravity of mercury is 13.6 and the glycerin one is 1.26, we want to calculate the pressure difference between point A and B. So in such problem, the solution or approach to the problem is pretty straightforward. We just need to start from, for example, point A and then move upward and downward through the material to point the other point like point B. And for example, if you started from point A, be careful PA, you just need to consider plus rho GH when you move downward, and because the pressure increases, and minus rho GH when you move upward, because as you move up in any fluid, you will reduce the pressure on top of your head. That's the feeling of that. Let's start the problem and jump to problem to solve it. And the other point, when you are provided with the specific gravity, so this is the specific gravity. The specific gravity, we show it by SG, and that's nothing but gamma, for example, of mercury to gamma water. SG can also, and gamma is a specific weight. This is a specific weight of a material, either liquid or let's have it like gamma is equal to rho times g. A specific weight is nothing but density times g. So in order to do so, you can like consider specific g of a material like mercury is density of mercury over density of water. So if somebody tells you the specific gravity of mercury is 13.6, in the other word it just says rho m, density of mercury is 13.6 times density of water. That's how we approach our problem. Now let's start the problem. Start at point A and move through point B within different fluid. So P at point A plus this amount in meter, 0.125 in rho GH, rho W times G, and this is our H, this height. Then we moved downward in mercury by the depth of 1 meter minus 125 millimeters, which make it like 0.875 rho mercury times G. Rho mercury, we talk about it, it's 13.6 times rho W because SG is 13.6, and then move upward, so negative zero point 0.5, which is half meter times a rho glycerin times G, which is a 1.26 times rho water. And if you do, then we reach to point B. So PA minus PB, so definitely rho W in SI units, you can consider it like 1000 kg over meter cubed, and G considered to be 9.81 meter per second squared. And if you do the math, it just gives you PA minus PB. Pressure difference between point A and B is 111.78 kilopascal. And let's move to our multiple choices. and see which one is the most close answer to our problem, and you can easily see the choice B is the answer. Thank you. We'll solve more problem in hydraulic engineering and also fluid mechanics. Thanks a lot.